Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to talk more about classes and objects. In a previous lecture, we started going over code organization. We do this so we can reuse parts of code so we use less statements, quickly find bugs or errors, and easily add or extend functionality. Java organizes its software first inside of projects, then inside of classes, and finally inside of methods. We've been discussing classes, and classes are a way that we can create classifications of objects. Instances of a class are referred to as an object, and they provide a blueprint of these objects. These include the shared qualities and characteristics. Classes combine together data with methods, and we can start thinking of classes as nouns. Now today we're going to focus more about objects and memory. As it's been discussed before, programs have different sections of memory. For instance, there's one section called the stack or the call stack. This is where methods are put inside of memory. They are pushed and popped on the call stack as they are called and as they complete. Another section of memory is called the heap. The heap is where we are dynamically allocating each one of these instances of classes that we call an object. Every time we have used the reserved word new, followed by a constructor, this is the section of memory where these objects are being created. Now in this diagram over here, you may notice that the stack looks like it's moving in this direction, and the heap is moving toward it in the other direction. This is how the stack and the heap functions inside the memory of a process. They grow from one side to the other toward one another. So every time we call a method, it is added, it is pushed onto this call stack and it moves in this direction. And every time we dynamically allocate a new instance of a class called an object, we add that to the heap and it moves in this direction. However, the stack and the heap are not the only parts of memory. And today we're going to be focusing on the data section of memory. This is where we bring up the idea of statics. Now, static methods and properties are created statically. Now, this is opposed to being created dynamically, just like the instance variables and the methods that we've been writing. Every time we dynamically allocate a new instance of a class, these methods and these instance variables are created inside of memory inside of the heap. However, when we refer to static methods and properties, they are created one time in the data section of memory. This means that static methods and the properties are shared across all of the instances. And this is very unlike dynamic methods or properties that are unique to each instance. Think of it like this. When we had several instances of cats, we had one cat's name be Mr. Flufferkins. That was unique to that cat. Another one, we had another cat called Dr. Boots. That name was unique to that cat. Whenever we are referring to instance variables and also the methods that we have been writing, these are dynamic variables and methods, and they are created uniquely for every single object that we construct. Now on the other side of this, when we refer to statics, we use the reserved word static to denote that this is going to be statically created in the data section of memory. One important aspect that's going to come up a lot is you cannot use the reserved word this to call any static methods or properties. This is the self-referential pointer that points to that instance's properties or methods. Remember, statics are not unique to one object. They are shared across every object. Now, in order to create a static property, you would start off, generally use the scope public, followed by the reserved word static, the type, and then the ID. And here's an example of a static integer. Furthermore, static methods do not require an instance of an object to be called. They can be called directly from the class, and this is why they're sometimes referred to as class methods. Before, it was very important to notice that if we were going to call a method from an instance of a class, we had to make sure that that instance even existed inside a memory. In other words, we had to make sure that that instance was not null. This is not true for static methods. They are defined one time in the data section. They do not require an instance at all. Now, when we are defining a static method, we start out generally with the scope public, followed by that reserved word static once again, and then the rest of this just looks like a normal method. The return type, the identifier, parameters, and then the body of the method. An example of this would be this addition method where its public static returns an int, and then it takes in two integers a and b, adds them together, and then returns the value. So when would you use a static method opposed to the other methods, the dynamic methods, that we've been writing? Static methods are great when an action does not pertain to one particular instance. In other words, if this action does not require any of the instance variables, or this action does not really pertain to a particular object, then you can create them as static. And in this way, what we can do is define this method once. This saves us memory as we do not have to redefine that method for every single instance. It is defined once only. And to reiterate, whenever we are talking about static methods, we cannot use the reserved word this to call static methods or any properties. Now, in order to call the static method, as mentioned before, you do not have to create an instance. You can use the class's identifier, followed by the dot, and then the static method itself. Going back to the previous example that we just saw, if we assume that the name of the class was simple math, we can just call addition from that. We didn't have to create simple math s is equal to new simple math and then s dot addition. We just call the method from the class identifier itself. And once again, this is why static methods are sometimes referred to as class methods, because they can be called directly from the class, and not an instance of a class, in other words, an object. Now, there are some rules when it comes to static methods. Static methods can call other static methods. Dynamic methods, the other ones that we've been writing, can call static methods. However, static methods cannot call dynamic methods directly. These methods can only be called when an instance has been constructed. Think of it just like when we were demonstrating this inside the main method. The main method is static. And so, if we wanted to call a method from a class, we first had to construct an instance of that class and then call the method from there. However, even within inside the main method, if there were other static methods, the main method can call those directly. But once again, static methods cannot call dynamic methods directly. Now, there are some common classes that use static methods that we have seen before. One of these classes is the math class. Now, the math class is built into Java and it provides many mathematical functions. But the big thing to remember is this did not require an instance of math to use those methods. Think about it in these terms. Why would we need a unique object of math in order to use these methods? It doesn't really make sense, because we don't need to create math m is equal to new math, and then math m1 is equal to new math. We don't need separate instances of math to just use these functions. All we need are these methods that provide this type of functionality, which makes sense to make them static. So some of the methods that are built into that math class are like power, absolute value, max and minimum. And notice, this is the name of the class math, and you can call them directly from the class itself. This indicates that these methods are static. They're defined one time only, and then we can use them directly from the class without creating an instance of that in order to call them. Now, some other useful math methods are ceiling, floor, square root, round, and also round. Now, going back to a previous lecture, notice that we have two different definitions of this method round. One takes in a type float and one takes in a type double. Remember, whenever we have the same methods that have the same signature or definition, but with different parameters, these are called overloaded methods. Another class that uses static methods are the wrapper classes. Wrapper classes basically wrap around primitive types that provide very common functionality and constants for these types. One that we've seen before is integer. One of the most common methods that we've seen in our examples is parseInt, where this method, which is static because notice, this is the class, this is a call to the method, but this method takes in a string and then converts it into an integer. Now these two are properties that are built into the integer class that provide the maximum integer value while also the minimum integer value. And in fact, both of these are static. As you can see, they're called directly from the class itself. Another similar class is the double wrapper class. This one provides the property max and min value, which will give you the maximum and minimum double value, and also the functionality parseDouble, which takes in a string and converts it into that type double. Another very useful wrapper class with a lot of static methods is the character class. Now, a lot of these methods look very similar to strings. And as mentioned before, strings are just basically an array of characters. The characters are a primitive type. The string is a collection of them that is a class type. Now, some of these methods is you can do character.toUpper, toLower, to upper or lowercase a character. You can even ask, is this character uppercase and is this character lowercase, true or false? You can also use the functionality to ask, is this character a letter? Or is this character a digit? Or is this character a space? These are just examples of a lot of different static methods that we have been using before. Now with that, let's see an example of how we can start creating static methods. In a previous lecture, we started going over this pet manager, where basically the idea was we were expanding from just having cats to having multiple kinds of pets. So we have this base class pet, which combines the attributes name, age, weight, and this special type called pet type, which is an enumeration of all of these different types of pets. After that, we went through the various steps in order to create the class. We defined the class, we created the instance variables, we created the constructors, we created accessors and mutators for every single instance variables, and the mutators checked for errors. Then we created some other useful methods, toString and .equals, and then we created an overloaded method where we could give these pets complements. Inside of another class, petPlace, this is where we had our public static void main method where we created instances, in particular 3 instances, 3 objects of type pet, where this was our default pet, this was Mr. Flufferkins, a cat, this was a dog named Roofles, and then we gave complements to the cat and the dog. Now going back to the pet class, what we're going to do now is create static methods. Now once again, static methods are not unique to every instance. They are defined in the data section of memory one time only. Static methods are great for providing functionality that can be shared across all instances. So as I'm thinking about this, I'm going to come up with a couple of static methods that might be kind of useful for our purposes. Now let's say that in this example, we were to find a new pet. But with this new pet, we haven't given it a name, we don't know the age of the pet, and we haven't weighed it yet, so we don't know those properties, but the one thing that we do know is the pet type. So maybe what we want to do is create a new instance of a pet, but only providing the type. We could create another kind of constructor, but in this case, I'm going to demonstrate how you can use a static method to create an instance of a new pet. So starting out, we make the scope public. Now, in order to define this as a static method, we use the reserved word static. Now we're going to return an instance of a pet, and we're going to call create new pet, providing a pet type, AT. Now before I move on, I want to show one quick error. What if I were going to call this.setType AT? What's going to happen? Well, notice this. We have a syntax error on the word this. Inside of static methods, we cannot call a non-static method. setType, if we notice up here, this is not a static method. It is dynamically created for every instance that we create of a pet. Static methods and properties are shared across all instances, so we cannot use the word this. What we need to do is create a new instance of this pet, set its type to AT, and then return that new instance. So let's just create a default pet. Pet new pet is equal to new pet, and we'll just call the default constructor here. Now we have this new instance that we call new pet. Now we can set its type to this AT. New pet.setType AT. The type is unique to this instance. It is unique to this object that we call a pet. Now, as this is not a void return type, we must return an instance of a pet. Well, let's just return the new pet. Now what we can do is use this method in order to create a new instance of a pet, just providing a type. Let's see how that works. Back inside the pet place, here's what we're going to do. We're going to define a pet, pet04. Now we're going to assign this to a new instance of a pet by calling. Now notice, we're just using the class's identifier pet. If I call pet.createNewPet, pet type, let's just say hamster, then what that's going to do is from this static method, providing this pet type, it's going to create a new instance of this pet, assigning the pet type to hamster, and then assigning it to this instance here. We can see how this works by calling system.out.println pet04. And you'll notice, this is the new instance of the pet that was created using this static method. Going back to the pet class, this is a very common static method which will just create a new instance of a pet. But there's another common static method as well. Let's say within this example that I really liked a pet that I had. I liked it so much I wanted multiple copies of that pet. In other words, I wanted to be able to clone the pet. So here's what we're going to do. We're going to create a public static pet. And we're going to call this one clone pet. Pet AP. So we're going to clone a given instance of this pet. But before we do that, we need to check if AP is equal to null, then we need to return null. We need to verify if this pet that we're about to clone even exists. If we're going to clone nothing, well, then we need to return nothing. But more importantly, if we're going to call methods from this instance of this class, then we have to make sure that it even exists dynamically inside a memory. Now what I want to do is clone this instance of a pet by simply storing all of its properties and then using those properties to assign to a new instance of a pet. Now watch how I do this. I'm going to return What am I returning? A new instance. A new instance of what? A pet. Now, I'm going to use the parameterized constructor, and I'm going to use both the parameterized constructor to set the properties of this new pet by using or getting the properties from this pet AP. So the first parameter was the name. How do I get the name? AP.getName. Next was the age. How do I get the age? AP.getAge. Next was the weight. How do I get the weight? AP.getWeight. Finally, it was the type. How do I get the type? AP.getType. And in this very simple line of code, what I have done is created a new instance of a pet. Assigned the pet's property to each one of the properties given this pet. Assigned it to its name by getting its name, its age by getting its age, its weight by getting its weight, and its type by getting its type. Then, once I have done all of this and constructed this new instance while also setting all of its properties, I just returned it back. Let's see how this works. Let's say that we create a pet, pet05, is equal to pet.clone, well, pet04. Now let's see what happens if I system.out.println pet05. Now as we print this out, we print out the properties of this new pet, pet5, which has the exact same properties as pet4. So in fact, we've created a clone of this hamster. Now going further with this, let's see what happens if I make these two calls. System.out.println pet04.equals pet05. And let's check the memory addresses. System.out.println pet04 is equal to pet05. What do you think will print out here and here? Well, sure enough, the call to dot equals checks all the properties in pet4 versus pet5, which has the exact same name, age, weight, and type. This returns false because pet4 is at a different memory address that was dynamically allocated than pet5, which was also dynamically allocated. Remember, if we're checking the contents of an object, we should use the method equals. If we are checking the memory address, we should use double equals or not equals, and more often than not, we need to use that to check whether or not an instance exists, so in other words, if it's null. Now outside of these examples, these are two very common static methods that we can write for classes. Creating new instances by giving some of the properties and also returning that new instance can easily be a static method. Another one is cloning something. So if we want to basically take an instance and make a separate clone of it, we can define a method in order to do that. And once again, the reason why we made these methods static is because they do not pertain to any particular constructed instance of this class. We're using these in order to create these instances or clone an instance by providing another instance. Static methods and properties are defined one time only inside the data section of memory. We do this to provide functionality that does not pertain to any one particular instance. And with all that being said, I'll see you next time.